Can you help me review this trig stuff? I keep mixing up my sines and cosines.
Sure. Let's start with right triangles. Those are the ones we use more often.
Like this?
Yeah, one of the angles is 90 degrees. In this case, we can use the Pythagorean Theorem.
A squared equals b squared plus c squared.
Right, where A is the larger side, the hypotenuse of the triangle.
Why can't we just add b and c directly? Why do we need to square them?
It has to do with the fact that B and C are perpendicular to each other. This is a special rule in geometry for adding the sides of a right triangle together.
So we can always add the sides of triangles like that as long as they're perpendicular?
You got it.
How do sine and cosine fit into all this?
Let me show you. Choose one of the remaining angles in the triangle.
Okay, I'll call this one angle theta.
So the sine and cosine are mathematical functions with specific definitions. The sine of theta is the ratio between the length of the side opposite to the angle and the length of the hypotenuse. The cosine of theta, on the other hand, is the ratio between the length of the side adjacent to it and the length of the hypotenuse. There's also the tangent of theta, which is the ratio between the length of the side opposite to the angle and the one adjacent to it. It's also good to know that the tangent of theta is the ratio between the sine and cosine of theta.
So when should I use sine and when should I use cosine?
It really depends on what angle you're using and what you're searching for. You always have to look at a drawing before deciding, because things would be different if we had chosen to use this other angle, we'll call it alpha, instead. Try it yourself. What would be the sine of alpha?
Okay, so the sine of alpha is c over a, because c is the side opposite to alpha. The cosine of alpha is b over a, and the tangent of alpha is c over b.
You got it. You can't just memorize it, though. You have to look at the situation.
Okay, I'll keep that in mind.
Anything else?
Yeah, what is that arctan, or tan to the minus 1?
Oh, you use that when you know the side lengths, but you want to figure out what the angle is.
How?
Well, for example, let's say you knew that A was 5, B was 4, and C was 3. We could use the tan to the minus 1 function on our calculator to determine which angle has a particular ratio as its tangent. Like this. Theta is the angle with the tangent of 3 over 4, the sine of 3 over 5, and the cosine of 4 over 5. Try plugging it into your calculator. They should all give you the same result. I'm getting 36.9 degrees.
I got 0.6435. Is that radians?
Probably.
Well, I can convert that to degrees because I know that there are 180 degrees in pi radians. I got 36.9 degrees too. Let me try to solve for alpha now. Alpha is the angle with tangent of 4 over 3, sine of 4 over 5, and cosine of 3 over 5. Plugging in any of the three, I get 53.1 degrees. And that makes a lot of sense because I know that theta plus alpha must add up to 90 degrees. I feel so much better right now.
Great. There's a couple of things I want to run by you, though. For starters, tan to the minus 1 is written like the minus 1 is an exponent, but it's important to realize that it is not one. In fact, it's probably best if we got out of the habit of even calling it tan to the minus 1. The proper name is inverse tan, or it's sometimes referred to as arctan. The same goes for inverse sine and the inverse cosine. Oh, and keep in mind that the Pythagorean theorem we used before can only be used if you have a right triangle. For other triangles, we're going to use the law of cosines. Let me write that out for you.
Thanks for all your help.
Anytime.